I'm Harish. I'm currently based in United States, and I'm here to present our work on enhancing personalized recipe recommendations through multi-class classification. The idea was to enhance any type of recommendation through multi-class classification. So we proceeded with recommending recipes. For that, the main motivation of the study is to create a web application that suggests personalized recipes by analyzing the user-specified ingredients. And then users can customize their recipes based on their preferences and also visualize the ingredient networks on the recommended recipes. We'll discuss this in a moment. So yeah, so we started with collecting the data from this website. We web scraped the data using Beautiful Soup in Python, and we collected data for three data sets. So the first data set contained dietary considerations. It has diabetic recipes, gluten-free recipes, low carb, low fat, and standard, and similarly cuisines, African, Middle Eastern, Asian, Indian, European, American, Mexican, and similarly the course. So altogether, we got like almost 10,000 recipes, which resulted in 1.84 GB of data. So since this was like raw text data, there involved a lot of text mining and pre-processing, like removing stop words, extra white spaces, measuring words like cup, teaspoon, and etc., and comma-based ingredient segmentation and removing all the duplicates. So finally, the data was prepared, and it has the recipe name and the ingredients in the recipe and what type of class it belongs to in three data sets. So then there are some ingredients in different recipes, like example, chicken wings and chicken thighs, but we wanted that to be just chicken so that the final results will be a lot simpler to uh, refine the recipe. So for that, we used count vectorizer to convert the ingredients of the matrix to token counts and then tokenize them. So to get the similarities, we used Jacquard, Cosine, and Jaro-Winkler similarity scores. Jacquard didn't perform well because it checks the similarity of positions of each and every letter rather than the words. So but Cosine and Jaro-Winkler performed well. The difference wasn't much, but not good either. But they were able to capture most of the similarities. But we proceeded with Jaro-Winkler similarity score. So firstly, we started with, now we have all the ingredients and their classes. So we proceeded with using association rule mining technique. We applied both the a priori and FP growth algorithms from MLXtend library. So what it does is it gets an ingredient and gets the rules for the ingredient, and altogether, for example, if there is a garlic as an ingredient, it gets the rules with what it is frequently occurred in the data, like garlic and onion is occurred, garlic and tomatoes, garlic and basil, or garlic, onions, and tomatoes altogether is occurred frequently. With that, we use the threshold of, since the data is very less, like even though there are 10,000 recipes, a garlic can be just repeated only 100 times. We never know. So we used less threshold and resulted in almost like 900 rules or something like that. Since we got the rules, we use this specific strategy for recommendation. So for example, if user wants to have a recipe with garlic and basil, it finds the rules for each and every ingredient user provided. For garlic, if the rule was onions, and for basil, if the rule was tomatoes, we recommend the recipes with these combinations. For example, if the recipe has garlic and basil, we recommend it. If the recipe has garlic, basil, and onion, we recommend it. If the recipe has garlic, basil, onions, tomatoes, we recommend it. We recommend it. So we make sure that all combinations are repeated in the recipes we recommend. Since there are like 10,000 recipes, even after the association rule mining, we, for example, for the previous set, like garlic and basil, if there are like for 10 from 10,000, we can recommend 500 of those, but user can't see each and every recipe and decide what. So to further refine those, we use classification techniques. We train few classification algorithms separately on the three data sets. So for example, if there is a recipe with the ingredients garlic and sesame, it will automatically classify that as an Asian cuisine or low-fat dietary concentration recipe. So from that, it gets idea of what the user wants and tries to refine the recipes further. So we used cane and random forest, stochastic gradients, and multinomial naive Bayes and XGBoost on 3 datasets separately, and furtherly used hyperparameter tuning on to get the good scores. And finally, SGD gave a good prediction score. The scores can be seen here. So for the cuisines dataset, it was like 80.13% with 6 classes, which is good. And for meal course dataset, it was 70.46, which is also good. But for the dietary considerations, it was 50.67, because there may be a recipe that is included in diabetic and also low carb, or maybe in gluten free too. So that's why it wasn't able to classify very better, but it was almost good that it could classify diabetic and gluten free good than the others. It was mainly confusing between the low fat and standard dietary consideration data. So now what we did was, for example, if we take garlic, basil, and tomatoes, onions, this may be classified into like Asian or in the other data set main dish. So what the model does is takes all these and runs the model and gets what it is belong to. Like maybe does it belong to an Asian cuisine or American, or all it checks in all 3 datasets and gets the main uh, main classes that it belongs to. So from that, we refine those that are only in the uh, classified classes. So now the recipes are recommended. We further went on to make it a little bit visualized for the user. So we use network analysis from by 5S and network X libraries in the Python. So what it does is, from the recipes that we recommended, it takes all the ingredients and draws a network map. For example, this was the network for the garlic, butter, and tomatoes. So like there were some 150, around 150 of the recipes. Let me, yeah. So this was deployed in this. I'm gonna just play this video how the app works. So the user enters some ingredients in the box. With that, the association rule mining and also the classification models from, and get some data sets. It was like 116. So from that, with the recipes we recommended, the user can now see the network. So for this, for 116 recipes recommended, this is how the network looks. So now the user can see their network, and maybe they wish to not have pineapple in their recipe, so that they can delete that node and see how the uh, network looks. And based on that, the recipes we recommended will be modified. Each and every color represents each and every different class as seen below. Like it may purple may be Asian and white may be some other thing. Sorry. So if the users want to further refine the recommended recipes, they can select the categories and say, so here finally we recommended 15 recipes for these 3 ingredients. So this is how the work went. So we went on just from 3 ingredients, mainly just from ingredients we wanted to recommend recipes for the user. So the future work may include this extending this application to recommend nearby restaurants. After we getting the recipes, maybe include the real-time data obtained from web scraping from third-party applications like Google or Uber or something like that, and recommend nearby restaurants. That would be a good idea. And also maybe include user ratings and comments for each and every recipe, so that the new user will better know what recipe they're gonna eat. So that's it. Thank you from my side. Yeah, thank you.